Hello students, welcome to Vyas Edification Kota. In this session of NCERT discussion, we are going to deal with the chapter Matrices and the very lovely miscellaneous exercise based on Matrices chapter number 3 of NCERT class 12. That's what we are going to deal with today. Let's discuss this question which says let A is a matrix which is 0, 1, 0, 0. Show that AI plus BA whole power n is equal to a power n I plus n a power n minus 1 times b times a, where I is the identity matrix of order 2 and n belongs to a natural, right? So how do you think we can approach this kind of a question? One of the approaches which the NCERT people love to follow and which they want you to solve using principle of mathematical induction. One of the approaches which they follow is using principle of mathematical induction. So we can discuss this question using principle of mathematical induction, or we can also discuss this question using another approach. What is that approach? Let's take a look at that approach first, and then we'll see the first approach, that is PMI. So the other approach that I'm talking about is when we have two matrices I and A. Now there's a special thing about these two matrices I and A. I and A are two matrices for which the product IA is equal to the product AI. That is, they commute with each other. They are commutative. They follow the commutative law, right? In case of product. Since they follow the commutative law in case of product, we can have very interesting thing over here. AI plus BA, this. Power n can be simplified as a binomial expansion. What do you mean by that? As a binomial expansion, yes. What I'm talking about is this can be expanded very easily. For example, had I had AI plus BA whole square, this could have been written as AI plus BA times AI plus BA. Okay, this is for example, right? So I can multiply them together. This would be A square times I square, okay, plus A B I A plus B A I plus B square A square. This is what you can observe, right? These are the terms that you will obtain by simply applying the distributive law. But observe, this IA will be equal to this AI because the matrix I commutes with the matrix A, and this will become A square I square plus 2AB IA plus B square A square, right? So you may clearly observe that what we have done over here is nothing but just the expansion of this. This is A plus B whole square, and what I have done is this is A square plus 2AB plus B square. I can write it in this form, or you can read x plus y whole square is x square plus 2xy plus y square, right? So the powers, the expansion of powers of such binomials, those results, all of those results hold for this particular kind of an expansion as well. This particular expansion where AI is a matrix, BA is another matrix, right? So such a result holds? Yes, such a result holds. What else? If such matrices commute, then such a result holds. What else is important over here in this question is, if you may observe, this is matrix A, which is 0, 1, 0, 0. The important thing to observe over here is that if I find A square, what do I get? This is 0, 1, 0, 0, A times A. And what is this matrix equal to? Please find this product first. 0 times 0, 1 times 0 will be 0. 0 times 1, 1 times 0 would be 0. 0, 0 times 0, 0 would be this. 0 times this. This is actually the null matrix. This A square is actually equal to 0. And once A square is equal to 0, A power 3 would also be 0. A power 4 will also be 0. A power 5 will also be 0. All powers of A greater than or equal to 2 would be 0 for this particular matrix, right? So this is the given expression in the LHS, and I want to expand this expression using our concepts of algebra. And what I do is, this is NC0 AI power n plus NC1 AI power n minus 1 times BA, plus the next term would be NC2 AI power n minus 2 BA power 2 plus ... There will be plenty of other terms as well. This is the binomial expansion of this. And remember, this whole expansion holds because A and I matrices commute with each other because of that product commutative. Right. So keeping this in mind, once we observe this thing, what do you think? happens to this term? You may observe that a square, this NC2, nothing happens with this. A power n minus 2 is okay. I power anything, I power n minus 2 would be equal to I. Okay, matrix I. B square is okay. What happens to this a square? Observe, in this given question, this a square is actually 0. Okay, and for this given question, this a square is 0. What happens to the next term? In the next term, you'll have a cube, which will be 0. In the next term, you'll have a power 4, which will also be 0. So every term coming after this, that is this term and any further term, will actually be equal to 0, right? You multiply this matrix with anything, that complete matrix would be 0. The matrix that you will get is a null matrix, right? And every other term after this will also be a null matrix. So this here is a 0, and what else remains? NC0 is 1. This is a power n, I power n. I power n is I only, right? Plus NC1 is n, a power n minus 1. I power n minus 1 is I. This is b times a, and what you get over here is a power n I plus n a power n minus 1 b I a would be equal to a. So this expansion is equal to this. A power n times I plus n a power n minus 1 times b times a. This is what you get, and this is what we started with proving, right? This is what we wanted to prove. We have proved that, yes. But this is using ideas of binomial. Okay. Now what do the person want? What do the NCERT people want in this? NCERT people want you to solve using principle of mathematical induction. So if you're only looking for scoring in board examination in such a question, so for writing the solution as per the board examination, what you'll have to do is you'll have to use PMI. So now let's discuss PMI first. What does principle of mathematical induction say? Principle of mathematical induction says that if you want to prove any statement, let Pn, if you want to prove this, so step 1 says for n greater than equal to 1, n belongs to natural. If you want to prove this statement for this is condition for all natural numbers greater than equal to 1, right? Right, for all natural numbers. This number could have started from, let us say, 4, 5, 6 also. So in case the lowest value is 1 over here. So in the first step, what we'll check is whether P1 is true or not. Okay. Since we want to prove this, P1 may come out to be true, right? If P1 comes out to be true, then in the second step, we assume that Pk is true. Assume that Pk is true. In the third step, prove that Pk plus 1 is true. We'll prove that Pk plus 1 is true using this assumption that Pk is true. Okay, those are the steps involved in principle of mathematical induction. Any proof involving principle of mathematical induction will use these steps, right? What is that? That P1 is true, then whenever Pk is true, Pk plus 1 is true. Once you prove this by principle of mathematical induction, you can say that the statement Pn is true. What happens here is actually, since 1 is found to be true on the basis of this result, that Pk is true implies Pk plus 1 is true. P1 will imply P2, P2 will imply P3, P3 will imply P4, P4 will imply P5, and on and on. At the end of the day, you can say that Pn is true for all natural numbers. That's the idea behind principle of mathematical induction. And now let's take a look at this question. Let A equals this matrix. Show that AI plus BA power n is equal to this. So let us call this a statement Pn. Pn is the statement. Let Pn is this statement. What is this statement? AI plus BA power n is equal to A power n I plus n a power n minus 1 BA. This is what you have, right? Okay. So first step that is involved over here is, this is step number 1. What is that? P1. What does P1 say? P1 says that this is AI plus BA power 1, which is equal to what? Can you observe that? A power 1 times I plus 1 is gone, A power 0 is gone, this is BA. And can you observe that AI plus BA power 1 is equal to AI plus BA? P1 is true. So what we note over here is that P1 is true. Okay. That's the first step. What's the next step? Assume Pk is true. Assume Pk is true. That is, what does that imply? Ai plus Ba, instead of n, I have to substitute k. So Ai plus Ba power k is equal to a power ki plus k times a power k minus 1 times Ba. Observe that. Instead of n, I have written k. Instead of n, I have written k at all places. And we have assumed that this is true. Now, on the basis of this, we are supposed to prove step 3. Prove Pk plus 1 is true. That is, what does that imply? Pk plus 1. Instead of n, we have a k plus 1. So, let's replace it. Ai plus Ba power k plus 1 should be equal to, we are supposed to prove this. This is equal to a power n, which is k plus 1 times I plus k plus 1 times a ki power k plus 1 minus 1, which is k times b times a. This is what we have. We are supposed to prove this statement. Okay. For proving this statement, what we can do is we can begin with the LHS, right? Now, our final focus should be on proving this. Let's begin with the LHS. What is the LHS equal to? LHS is AI plus BA power k plus 1. Let's separate k and let's separate the other term. AI plus BA. Let's write it as this, right? What we have done is we have separated that power of k plus 1 into power k power 1, right? What next? Now, this expression is already known from here. This expression is already known from here. Known from here, yeah, we have assumed that this is true, okay? So, AI plus BA whole power k is equal to something. Let's substitute that. What do we have over here is a power k I plus k times a power k minus 1 BA. This is what is there. And then you have AI plus BA again. And then you have AI plus BA again, okay? What next? After this, what we are supposed to do is simply simplify this expression by multiplying. Let's do it. So, let's apply the distributive law. This multiplied by this, what will you get? Is a power k, a power k plus 1 times I square, which is equal to I only, right? This is what you get. What next? Let's multiply this with the next one. What you get is a power k times b, IA would be actually equal to a. The product of matrix I with matrix A is A. What else? This multiplied by this, what you get over here is k is okay. A times a power k minus 1 is a power k. Okay. What else? B times A times I. A times I would be simply A. Right? This is what you get. Is that okay? Yes. What next? What next? The next thing that we get over here is this multiplied by this. And what is this equal to? K times a power k minus 1 b square times a, which is a square over here. Right? That's the last term. Those are the 4 terms that we get. Okay. Now, for this matrix A, over here, a square is equal to 0, 1, 0, 0, which is this, and this product, something which we have discussed some time back, this product is simply equal to 0, 0, 0, 0, that is the null matrix, okay. Since this is a null matrix, this whole overall term would become 0, right. What about the other terms? This will be equal to a power k plus 1 times I, which is okay, plus what else? Let's take out whatever we can common, okay. What do we have over here is a power kb times a. So we can take that out common, we get k plus 1 a power k b a plus the rest. This term would be simply 0. This is what I get. And observe this expression obtained over here and compare this with the RHS over here. A power k plus 1 I, we have a power k plus 1 times I. What is this? A power k, this is k plus 1 times a power k times b times a, and we have that exact same thing over there. Yes, this is equal to RHS. So we wanted to prove pk plus 1, and for proving pk plus 1 is true, we wanted to prove this is equal to this. Okay, and what is this? This is ai plus ba power k, right? We wanted to prove this equals this. And for proving that, have we done that? Yes, this LHS is equal to RHS using this PK. Okay, step 1, 2, 3 done. Therefore, by PMI, we can say that Pn is true for n belongs to natural. For all n belongs to natural numbers, for all natural numbers, this statement Pn is true. That's what we have proved. So this is the idea of proving using principle of mathematical induction. And I hope that makes sense. Yeah, that is all for this question over here. Let's discuss this question next. If A equals this matrix 1, 1, 1, 1, 1, 1, 1, 1, 1, okay, prove that A power n equals this where n belongs to natural. Okay, how do we go about proving this? So one of the approaches which the NCERT people love is the principle of mathematical induction, and we can solve this question using principle of mathematical induction. Okay, is there any other approach? Yeah, there's one more approach, that is you can observe patterns. You can observe, what you can do is you can observe patterns, that is if you have already have A, let's find A square, let's find A power 3, A power 4, and we can observe that this kind of a pattern will be followed, right? Any other approach? Yes, there's one PMI also. Let's use that PMI. Okay. So principle of mathematical induction says that let us assume the statement Pn. What is the statement Pn? Pn is this statement. A power n is equal to this over here, 3 power n minus 1, 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 and there's another row. What is that row? This is 3 power n minus 1, 3 power n minus 1 for n belongs to natural. Now for proving this, the principle of mathematical induction says that we have to apply 3 steps. We have to apply 3 steps. The first step is this particular result should be true for n belongs to natural. So the first step, we'll check P1. What does P1 say? P1 says A power 1 is equal to 3 power 0, 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 which implies A is equal to 1, 1, 1, 1, 1, 1, 1, 1, 1. Can you observe that? This A power 1 is A and 3 power 0 is 1, right? So A equals to this, and is this statement true? Yes, this is true. Step 1 says P1 is true. So P1 should have been true, yes. Once you have found that P1 is true, the next step that is involved is PK. Assume PK is true. Assume that PK is true. Okay, so what does that imply? Implies that A power k, instead of n, what I'll do is I'll substitute k, right? So A power k is equal to 3 power, instead of n I am substituting k, this is 3 power k minus 1, 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 again 3 power k minus 1, 3 power k minus 1. That's all that we have, right? This A power k is equal to this. Once we have assumed this, now it is time to apply the step 3. What does step 3 say? Step 3 says prove Pk plus 1 is true. That is, what we want to prove is, instead of n, if I substitute k plus 1, the result, that the statement should be actually true. So what we have over here is A power k plus 1 is equal to 3 power k, 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 3 power k. This is what we have. We are supposed to prove this one. Okay. So for proving this one, what do we need? We need to start with the LHS first. Okay. Let's begin with the LHS. LHS is equal to A power k plus 1. Now what is A power k plus 1 equal to? A power k plus 1 can be written, we have to use this expression over here, right? We have to use this statement since this is assumed to be true. So A power k plus 1 is equal to A power k times A. Now what is A power k? You may observe that A power k is this 3 power k minus 1, 3 power k minus 1, 3 power k minus 1. Okay. So let's use that. This is 3 power k minus 1, 3 power k minus 1, 3 power k minus 1. This is again 3 power k minus 1, 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 3 power k minus 1. Same. And what is A? It has to be multiplied with A. This matrix has to be multiplied with A. A is, this is the matrix A. This is the matrix A, as you can clearly observe, right? Now, let's go about multiplying these two, and we'll require some more space, yeah. So, can we erase this? Yes. This is Pn is this statement. So, let me write this is Pn over here. Okay, and P1 is true. Nothing else is important in this. So, let's get rid of this one. Once we get rid of this, let us solve that LHS, which gives me LHS is equal to what? LHS is equal to, multiply this first row with the first column. So, 3 power k minus 1, 3 power k minus 1, 3 power k minus 1 get added 3 times. So, this is 3 times 3 power k minus 1. Okay, and can I write it as 3 times 3 power k minus 1? Can further be written as 3 power k, but we'll write it in the next step, not an issue. These 3 get multiplied with this 1, 1, 1, and we get the exact same thing, right? So, this is 3 power k minus 1 into 3, which is 3 power k. The other terms would also be 3 power k, 3 power k, 3 power k, 3 power k. All of these terms would be 3 power k, as you can observe. This is also 3 power k, yeah. So, all the terms are 3 power k. And we started with the LHS. What have we obtained over here? This LHS is equal to this, which is actually the RHS of this sign, right? Which is equal to the right hand side of this, and this is what we started, which we wanted to prove. Is proof. Okay, so by PMI, by principle of mathematical induction, we can say that Pn, that is this statement, by the principle of mathematical induction, this statement that a power n equal to this, by mathematical induction, we can say that this statement is true. By the principle of mathematical induction, we can say that Pn is true, using, since we have followed those 3 steps of principle of mathematical induction over here. That's all? Yeah, that's all in this question. Let us discuss this question. If a equals 3 minus 4, 1 minus 1, then prove that a power n equals this, where n is any positive integer. Okay. How do we approach this question? So, one of the standard approaches which the NCERT people and the CBSE board people love is using principle of mathematical induction. Is there any other approach? Yes, such questions have been appearing in the JEE examination as well. So, I'll discuss one more approach. Let's discuss that shorter approach first. What is that shorter approach? Let's see. We want to prove that a power n equals this. So, given a equals 3 minus 4, 1 minus 1, can you write A as sum of 2 matrices? Can you write A as sum of 2 matrices? One of them is 1, 0, 0, 1. The other would be actually obtained from here by writing 2 minus 4, 1, and what will this be actually equal to? This will be equal to minus 2 over here, right? Can I write it as this? Yes. A has been written as sum of 2 matrices. Let us call this matrix is identity matrix. Let us call this matrix B. Let us call this matrix B. Okay. And once we have this, so a power n can easily be found. A power n is actually I plus b power n. Since matrix A is equal to I plus b, we can easily find a power n by writing I plus b whole power n. Okay. Now, these matrices B and I are such that identity matrix commutes with any square matrix, right? Identity matrix commutes with any square matrix. And since it has this kind of a property, I can apply a simple binomial expansion on this, right? Simple binomial expansion. This will be NC0 I power n plus NC1 I power n minus 1 b plus NC2 I power n minus 2 b square plus dot dot dot. These are the terms that I'll get, right? Now, the first term, observe the first term. This I power n is simply I, which is okay. I power n minus 1, which is I, multiplied by b will be equal to b only, right? Again, this is I times b square would be actually b square. Okay. B is already known to us. B is already known. Matrix B is very simple. B is 2 minus 4, 1 minus 2. Okay. What is matrix B square equal to? Let's find B square for once. This is 2 minus 4, 1 minus 2 times another 2 minus 4, 1 minus 2. B square is simply B times B, right? So let's multiply them together. And what do we observe over here? 2 times 2 is 4, minus 4 is gone, 0. 2 times minus 4 is minus 8 and plus 8 is 0. 1 times 2 is 2, minus 2 is 0. Minus 4 plus 4 is 0. Very interesting. This matrix here, B square, is null matrix. Okay. B square being null matrix, can we observe that B square is a null matrix, and this will imply that further B power 3 would be 0. B power 4 would also be null matrix. All of these would be null matrices, right? And so on and so forth, right? So the terms obtained after this and terms obtained after this would all be 0, 0, 0, 0, 0, 0, 0. So this a power n would be simply NC0, which is 1, I power n, which is I, plus NC1, which is n, times this is B. And rest all would be null matrix 0, 0, 0, 0, 0. So what we have done is we have simplified a power n and found it in this manner. This is identity matrix, which is 1, 0, 0, 1, plus n times B, n times the matrix B. What is the matrix B? This is the matrix B, 2 minus 4, 1 minus 2. And further what you obtain is this is 1 plus 2n, the first term A11, then 0 plus 0 minus 4n would be minus 4n, 0 plus n would be n, and 1 minus 2n is what I get over here, and this is a power n, and this is what we wanted to prove, right? Please observe 1 plus 2n minus 4n and 1 minus 2n. Right? This is what we wanted to prove. Have we proved that? Yes. Using binomial expansion, we have proved this. Right. What's so special in this, and why do the JEE people keep asking this kind of a question over and over again? Is this whole process over here, right? Even if we are not given this, we can use this kind of an idea and obtain this result on our own, right? We can obtain this result on our own, and in the options, generally one form or the other of this kind of a question is given, right? So such questions in the JEE can also be attempted using hit and trial. Hit and trial, yeah. We can substitute different values of n and check which of them are true for a square, a cube, a power 3 and all, right? That's another way of dealing with such questions using hit and trial. But this is kind of a sure shot approach, and questions have been asked on this. But what about right now? If you are talking about the CBSE board examination, they won't love this kind of a thing. They will hate this kind of a thing. Right. So since they hate this kind of a thing, what do they love? They love the long, arduous principle of mathematical induction, right? So let's attempt this question using principle of mathematical induction as well then. What does principle of mathematical induction say? Well, assume first of all Pn. Let's write this statement Pn first of all. What is Pn? Let Pn is this statement which says that a power n is equal to this matrix 1 plus 2n n minus 4n 1 minus 2n, where n is any positive integer, that is n belongs to natural. This is any statement. This is Pn for any n belongs to natural. Now for proving using principle of mathematical induction, we need 3 steps. What's the first step? The first step says that P1 must be true. What does P1 say? A power 1 is equal to, what you have over here is 1 plus 2. This is minus 4, this is 1, this is 1 minus 2. What is this equal to? This is 3 minus 4, 1 minus 1. And can you observe that this is equal to A? 3 minus 4, 1 minus 1. A equals 3 minus 4, 1 minus 1. A is equal to this 3 minus 4, 1 minus 1. And this implies P1 is true. Step 1 is check whether P1 is true or not. P1 has found to be true. Okay. Once you have verified that P1 is true, the next step that you will apply is you will assume that Pk is true. Second step, assume Pk is true. Now what does that imply? Assume that Pk is true implies that a power k is equal to 1 plus 2k minus 4k k 1 minus 2k. We have assumed that p power k, pk is true, that is, this is true. Okay. The third step after that, third step says that prove pk plus 1 is true. proof pk plus 1 is true. That is, what does that mean? Pk plus 1. So for pk plus 1, we in the LHS we have a power k plus 1 is equal to, in the matrix we have 1 plus 2 times k plus 1. And next you have k plus 1 over here. This is minus 4 times k plus 1, and what you have is 1 minus 2 times k plus 1 over here. This is what we have, right? This statement has to be proved. So for proving this, we'll have to begin with the LHS. Let's begin with the left hand side. Let's take a look at the proof. Proof says a power k plus 1 has to be simplified. Now for simplifying a power k plus 1, we know that we have to use that a power k. So let's write it as a power k times a. Now what is a power k equal to? A power k is that already known. A is already known. Let's use them. This is 1 plus 2k minus 4k, 1 minus 2k and k. What is the matrix A equal to? A is this 3 minus 4, 1 minus 1. Let's use that. Once we have written these two, let's multiply them together and see what we get. Okay. How do we multiply them? This into this minus this. Okay, so this is 3 times 1 plus 2k, which is 3 plus 3 times 2, 6k and minus 4k. This is what I get for A11. Okay. What next? This row gets multiplied with this. So minus 4 minus 8k and minus 1 times minus 4 would be plus 4k. This is what we get, right? What next? The second row gets multiplied with the first column. This is 3k and plus 1 minus 2k. Next, the second row gets multiplied with the second column. Minus 4k and minus 1 plus 2k is what we get over here. This is what we get, right? So that's the matrix obtained in the LHS. What next? We have to prove that this is equal to that matrix over there, right? So we have to write it in this form if possible. Let's simplify this further, and since we need more space, can we get rid of this? Yes. This statement is Pn, so let's name Pn over here. Let's name Pn over here, and let's get rid of this, right? So continuing with this further, which gives me LHS is further equal to what? This is 3 plus 2k, right? On simplification, this is 3 plus 2k. What next? What do we have over here is minus 4 minus 4k. You may observe this is minus 4 minus 4k. Okay. And here you have 3k minus 2k, which is k plus 1. Okay. What else? This is minus 1 minus 4k plus 2k would be minus 2k. So this is minus 1 minus 2k over here. Okay, have we obtained that thing? We don't think we have obtained exact same thing, but you can convert this into that form. Please observe this term. What is this term equal to on simplification? This is 2k plus 2 plus 1 would be actually equal to 2k plus 3 only, right? Minus 4k minus 4, that is present over there. 1 minus 2k minus 2, 1 minus 2 would be minus 1, that's present over there, yes. So those terms on simplification are this, or these terms in a complicated, slightly complicated form, that is in terms of k plus 1 would look like this, right? Let's try to convert each and every term in the form k plus 1, that is the required form. What you have is, this is 3 plus 2 times k plus 1. So what you have done is you have added 2, let's subtract the 2, okay. Let's take a minus 4 common over here, you get 1 plus k, right? This is already k plus 1, that's not an issue. And what about this? This is minus 1 minus 2 times k plus 1, and since you have subtracted 2, let's add a 2. This is what you have to be writing it as. And now you can see the required form. This is 1 plus 2 times k plus 1. This is what you have over here. What is this? This is minus 4 times k plus 1. Okay, what is this? This is simply k plus 1. And what is this? This is 2 minus 1. 1 minus 2 times k plus 1. Over here, this is a complete matrix, right? This is a complete matrix, and this is equal to the RHS. That's the proof. And since 1, 2, 3 are true, so by PMI you can say that Pn is true for n belongs to natural. By principle of mathematical induction, you can say that Pn is true for n belongs to natural. Those are the 3 steps that we follow for proving such kind of identities, such kinds of equations using principle of mathematical induction, right? That is all for this question over here. Let's discuss this question next. If A and B are symmetric matrices, prove that AB minus BA is a skew symmetric matrix. This question is actually repeated in the NCERT itself. We have already discussed this question in exercise 3.3, I suppose, one of the questions. It was in the form, it is given in the form of objective question, right? 11th question of that exercise. And again in the miscellaneous exercise, the same question appears. Let's discuss it again in this case, right? So if A and B are symmetric matrices, okay, and if A and B are symmetric matrices, they should be of same order, by the way, so that this can be defined, right? That's very important. If A and B are symmetric matrices, prove that. So given A prime is equal to A and B dash is equal to B, right? This is A transpose equal to A, B transpose equal to B. Since A and B are symmetric matrices follow this property, right? So we have written the condition for symmetric matrices directly in this manner to prove that AB minus BA is skew symmetric. Now, for skew symmetric, what do you want? The property of skew symmetric says, or the definition of skew symmetric says that for any matrix C, if C transpose is equal to minus C, if C transpose is equal to minus C, then the matrix C is said to be a skew symmetric matrix, okay? So for proving that this is a skew symmetric matrix, what we are supposed to do is, let's begin with this matrix. Let C equals AB minus BA. Now, we'll find the transpose of C first. Implies C transpose can be written as AB minus BA transpose. And simplify this using properties of transpose. See, what do you get? Do you get C? Do you get minus C or something else? Right? Since C is said to be a skew symmetric matrix, this C transpose should come out to be actually minus C at the end of the day. Right. So what do we have? AB minus BA whole transpose. The transpose can be brought inside, and what you have is AB transpose minus BA transpose. Now what is the property of transpose that you have used? That A plus minus B transpose is equal to A plus minus B. A transpose plus minus B transpose. That's simple idea. Addition and subtraction of two matrices. If you take the transpose of that combination, what you can do is separately you can take the transpose and then add or subtract those matrices, right? That's a property of transpose. What else? This product can be simplified as using once again AB whole transpose is equal to B transpose A transpose. That's a property of transpose for multiplication of matrices. So this is equal to B transpose A transpose minus this is equal to A transpose B transpose in the reverse order, right? So therefore C will become equal to what? Now observe, B transpose A transpose, once we have reached this stage, then we can think of using this condition, right? We haven't used this condition, let's use that condition, right? So B transpose is equal to B, A transpose will be equal to A, minus A transpose is A, B transpose is B. This is using 1 over here, given condition, right? What else? What else? Once you have BA minus AB over here, we wanted AB minus BA form. What we can do is take a minus common and this becomes AB minus BA. So, just a minute, this was C transpose in the LHS, right? This was C transpose in LHS. C transpose is equal to this, which gives me C transpose is actually equal to, can you observe, AB minus BA is nothing but C. Therefore, C transpose is equal to minus C. This was the stage that we reached. And since C transpose is equal to minus C implies C is skew symmetric matrix. C is skew symmetric matrix. What is C? C, that is AB minus BA. That is AB minus BA is skew symmetric matrix. That's what you have proved over here. That is AB minus BA is a skew symmetric matrix. That's what you have proved very easily. Is that all? Yes, that is all for this question. Let's discuss this next question. Show that the matrix B transpose AB is symmetric or skew symmetric according as A is symmetric or skew symmetric. Okay. There are two parts of this question which have been said, which is asked over here. One is that given A is symmetric, we have to prove that B transpose AB is symmetric. The second part says if A is skew symmetric, then B transpose AB will be skew symmetric. There are two parts of this question. Let's try to attempt both of them. The part 1, first of all, let's talk about that. Is symmetric, let's read this, is symmetric according as A is symmetric. Okay, so given A is symmetric, so given A is symmetric implies A transpose would be equal to A. Let's call this statement 1. Given that A transpose is equal to A, that's given, right? Okay, what next? We have to prove that B transpose AB. To prove B transpose AB is symmetric. Okay, this is what we want to prove. And let's take a look at the proof. If you want to prove that this matrix is a symmetric matrix, let's try to take the transpose of this matrix first. So for doing that, let's begin with let a matrix C equals B transpose AB. Let C is equal to B transpose AB, which implies C transpose would be equal to B transpose AB whole transpose. This is what we have, right? This is what you'll be getting. Okay, and we know one of the properties of transpose. What is the property of transpose? The product AB whole transpose is equal to B transpose A transpose. Although there's an extended version to this as well. There's an extended version to this. What is the extended version? I'll explain that. A1, A2, A3, ... An. If there are n matrices multiplied and we want to take the transpose, what you'll get is An transpose, An minus 1 transpose, ... A3 transpose, A2 transpose, A1 transpose. This is also known as the reversal law of transpose, right? Reversal law. And in case of product, what you get is the matrices multiply together. Once you want to take the transpose of that, you can take individual transpose and multiply them in the reverse order. That's what you can do. This is obtained by expanding this. Is this property written in the NCERT? No, this is not written in the NCERT. So you will not worry about that. What we'll do is we'll solve using this only. So what we have over here is there are two matrices. There are three matrices in all. Let us break them down into two parts. This is B transpose, let's say, and this is matrix AB, let us say, and we want to take the transpose. Can we do it? Yes. Once we write it as this is basically one matrix and this is another matrix. Okay, apply this property on this product. So what you get is the second matrix comes in the front and we take the transpose. The first matrix goes at the back and we take its own also its transpose as well. This is what we get. Okay. Can we get rid of this reversal law? Yes, we can get rid of this reversal law. But you will observe, I'll explain that this reversal law could be used over here as well, right? And once, let me derive this result first. So after this, what happens to C transpose is this AB whole transpose becomes B transpose A transpose. Again, I'm using that property. What happens to this B transpose whole transpose? This becomes B now. Since obviously the transpose of transpose is equal to the matrix itself. Since the transpose of transpose is equal to the matrix itself. So this is equal to this. Okay. You may please observe that I could have applied the reversal law directly on this and obtained this result directly. The order would have been reversed and we would have taken transpose of each matrix. The first matrix B transpose, the second matrix A transpose, the third matrix B transpose, that will be equal to B over here. We could have used that reversal law as well, right? Okay. So once you are clear this with this much, what next? We haven't used this condition yet. Okay, let's use this condition. Since we have obtained this stage of A transpose, let's use that. This is B transpose. This becomes A, this becomes B, and this is using this one. Okay, so this is B transpose AB. Okay, and what is B transpose AB equal to? B transpose AB is equal to C. We started with this, right? So this gives me C transpose is equal to C. Okay, which implies C is a symmetric matrix. C transpose equal to C implies that C is a symmetric matrix. C, that is B transpose AB, is a symmetric matrix. This is what you obtain, hence proved. That's a complete proof? Yeah, that's a complete proof. Okay, is that all? No, this is just the first part where we have proved for a symmetric matrix, right? Right. If A is skew symmetric, then B transpose AB should be a skew symmetric matrix. Okay. Now let's talk about this second part after this. Okay, let's get rid of this whole thing. So now we'll discuss this skew symmetric as A is skew symmetric. Okay. Let's discuss the second part. Given A is skew symmetric matrix. Now what does skew symmetric implies? Implies A transpose will be equal to minus A. Let's call this statement 1, which is given to us. Let's call this statement 1. A transpose will be equal to minus A. This is the definition of skew symmetric. And we are supposed to prove. What do we want to prove over here? Show that the matrix this is skew symmetric. B transpose AB is skew symmetric. Now, if you want to prove that B transpose AB is skew symmetric, we'll have to begin by taking the transpose of this matrix, right? Let's take a look at the proof. Let us assume, this matrix is denoted by D. B transpose AB is denoted by the matrix D. And now we focus on finding the transpose of D. D transpose is equal to B transpose AB whole transpose. And we just found that B transpose AB whole transpose, right? Reverse. B transpose will come first, after that A transpose, and the transpose of transpose would be actually equal to B after that. Okay, let's use this. This gives me D transpose is equal to B transpose A transpose times B. And what next? Since we have reached a stage where we have A transpose and A transpose, the value is already known, let's replace that. So this is B transpose times minus A times B using 1 over here. Okay. What is this equal to? This scalar minus 1 is multiplied with this matrix. That scalar can move around. It will not impact the matrix multiplication, and I can bring it at the front. This is B transpose AB. This gives me D transpose is equal to this. And what is this? This is something which we began with. This is equal to D. So this gives me D transpose is equal to minus D. For this matrix D, D transpose is equal to minus D implies D is skew symmetric. D, that is this matrix B transpose AB. D, that is this matrix B transpose AB is skew symmetric. And that is what we want to do prove. At the end of the day, that is what we want to do prove. I hope that's okay. Yeah, that is okay. And this is all that you have in this question. Let's discuss this question next. Find the values of x, y, and z if the matrix this satisfy the equation A transpose times A is equal to identity matrix. What will we do in this question? Not a very difficult thing to handle. You can easily handle this by solving equation, right? Substitute A transpose A and solve. What do we get? A transpose times A is given to be identity. Okay. What is the matrix A transpose equal to? And what is the matrix A equal to? And the product is equal to the identity matrix. So let's write the identity matrix on the right hand side. What is A transpose? First of all, A transpose is the transpose of this matrix 0, 2y, z. This is what we have over here. X, y minus z is what we have over here. X minus y, z is what we have over here. The rows and columns are interchanged, right? The first row becomes the first column, the second row becomes the second column, third row becomes the third column. Then a matrix A. Matrix A will be written as it is 0, 2y, z, x, y minus z, x minus y, z. Okay. What next? On the right hand side, you have identity matrix. Right. Let's find the product and compare each element, and let's see what we get on comparison. Okay. What do we get over here is the product. The first row gets multiplied with the first column. 0 times 0 is gone. X times x is x square, x square. This becomes 2x square. 0 plus x square is 2x square, right? What next? Multiply the first row with the second column. 0 times 2y is gone. Xy minus xy is gone. This is 0. Okay, this here is 0. What next? 0 times z is gone. Minus xz plus xz is also gone. This is again a 0. Okay, so this is 2x square, 0, 0. That's the first row for us. What about the second row? 2y minus y will get multiplied with 0xx. This is 2y times 0 which is gone. Xy minus xy will be 0. Oh, pretty interesting. Next, 2y times 2y is 4y square. Y times y is y square minus y times minus y is again y square. So we have 4y square plus y square plus y square, which is 6y square. What next? 2y times z is 2yz minus yz minus yz. So 2yz minus yz minus yz is simply 0. That's the matrix that you'll get. What next? This multiplied with this, z times 0 is gone, minus zx plus zx is 0. This times this, what you get is 2yz minus yz minus yz. So 2yz minus yz minus yz would be 0. What next? Over here, multiply this with this. So z times z is z square, minus z times minus z is z square, z times z is again z square. This is z square plus z square plus z square, which is 3z square, which is equal to 1 0 0 0 1 0 0 0 1. This is what we have. This is equal to this. Okay, and after this, what you want to do is simply compare, right? Compare and form equations in terms of x, y and z. So we see that 2x square will be equal to 1, 6y square will be equal to 1, and 3z square will be equal to 1. This is what you get. And from here you may observe that x will be equal to plus minus 1 over root 2, y will be equal to plus minus 1 over root 6, and z would be equal to plus minus 1 over root 3, and that is my answer for this question. That's all for this question that we have here. Is that all? Yes. Those are the answers. Those are the values of x, y and z. Let's discuss this. For what values of x? 1 to 1 times this matrix times this another matrix will be equal to 0. Okay. So there are three matrices multiplied together, and the result is a 0 matrix, null matrix, so 0. This is a 1 by 3 matrix, this is a 3 by 3 matrix, this is a 3 by 1 matrix. Okay, these two product are okay, the final order would be this, and since this is okay, the final order of the product would be 1 by 1. Let's multiply them together and see what we get. That's pretty simple, right? You'll get a 1 by 1 matrix on the LHS which is equal to 0. You'll get a single equation in terms of x which can be solved for x. Right. So let's multiply them. Let's multiply them together. What do we do? Let's multiply the first row with everything over here. This matrix multiplied with this matrix. So the first row gets multiplied with the first column. 1 times 1 is 1, 2 times 2 is 4, 1 times 1 is 1. 1 plus 4 plus 1 is 6 over here, right? This is 1 by 3, this is 3 by 3. The final matrix product that you'll get is a 1 by 3 matrix. Okay, the first row gets multiplied with the first column, this is 6. First row gets multiplied with the second column, 1 times 2 is 2, 2 times 0, 1 times 0 are gone, this is simply 2. Next, multiply this first row with the third column, 1 times 0 is gone, 2 times 1 is 2, 1 times 2 is 2, this is 4. Let's multiply this matrix with the other one, 0, 2x. 0 to x, and this is equal to the null matrix over here. This is equal to the null matrix over here. Let's multiply 1 by 3 and 3 by 1. We get a 1 by 1 matrix. What is that? 6 times 0 is gone, plus 2 times 2 is 4, plus 4x is equal to 0. And from here you can observe that 4 plus 4x equals 0 implies x equals minus 1. Simply implies x will be equal to minus 1, and yes, that is the required answer for this question. Simple, pretty simple. Let's discuss this question next. If a is 3, 1, minus 1, 2, show that a square minus 5a plus 7i is equal to 0. Okay. How do we go about solving this? It seems simple only. Doesn't seem very difficult. What we have to do is, we'll have to find a square. We'll have to find, we are already given a and we all know I, and we can calculate the value of this left hand side and observe what will it be equal to. Will it be equal to 0 or something else, right? By the way, this question is based on something called characteristic equation of a matrix. What is characteristic equation of a matrix? It has got something to do with determinants also. So not something which I'll be discussing over here. This question can be solved easily by finding a square first. So let's calculate a square. A square is a times a. What is that equal to? This is 3, 1, minus 1, 2. times 3, 1, minus 1, 2. What is this equal to? Let's multiply them together. The first row, first column, 3, 3, 9 minus 1 is 8. Okay. 3, 1, 3 plus 2 is 5. Minus 3 minus 2 is minus 5. Minus 1 plus 4. Minus 1 plus 4 is 3. This is a square for us. Okay, since we have already found a square, so therefore a square minus 5a plus 7i will be equal to what? This is 8, 5, minus 5, 3. Minus 5 times a. Now 5 times a would be, let's note 5 times a, this was 15, 5, minus 5, 10. And 7 times I is 1001. If you multiply it with 7, what you get is 7007, very easily. And what does that simplify into? 8 minus 15 plus 7 is actually 8 plus 7, 15 minus 15, which is 0. Okay, 5 minus 5 is 0. Minus 5 minus of minus 5 would become minus 5 plus 5, which is 0. 3 minus 10 plus 7. 3 plus 7, 10 minus 10 is 0. Yes, this is equal to the 0 matrix, and this is what we wanted to prove. That's the proof of this result over here, right? This is a complete proof. Yeah, that's a complete solution of this question. Let's take a look at this question. What do we have over here is a single variable x, and we are supposed to find the value of this x using this equation, right? The equation is complicated in a way because we have to solve for product of a few matrices, but you can observe this is a 1 by 3 matrix, this is a 3 by 3 matrix, this is a 3 by 1 matrix, right? These products are okay, and the final order that we'll get is a 1 by 1 matrix. The final order that we'll get is a 1 by 1 matrix, as you may clearly observe, and that 1 by 1 matrix will be an equation, it will give us an equation in terms of x. Let's try to find that. Okay, so what do we do? What do we do over here? We'll multiply this matrix and this matrix first of all, right? Let's do it. This is 1 by 3, this is 3 by 3. What we'll get is a 1 by 3 matrix. That's a row matrix. X minus 5 minus 1 gets multiplied with 1, 0, 2. What you get is x 0 minus 2, x minus 2. This is the first element. Okay. First row, second column. X times 0 is gone, minus 10 and 0. This is minus 10 only. Next, first row, third column. 2x minus 5 minus 3. 2x minus 8. This is what will 2x minus 8. Multiplied with the other matrix x 4 1 and equals 0 matrix. So what you get over here is, let's multiply them, 1 by 3 and 3 by 1. We get a 1 by 1 matrix. What will that be equal to? This is x times x minus 2, which is x square minus 2x. Minus 10 times 4 is minus 40, and 2x minus 8 plus 2x minus 8. This is what you get, equals 0. This is what you get, right? Since this is equal to 0, what I observe is, this gives me x square plus 2x minus 2x is gone. This is minus 48 is equal to 0, which gives me x square is equal to 48, or x equals plus minus 48 would be 16 into 3, right? This is 4 root 3. That is my answer for this question. So multiplication of matrices, if you can do that well, you will be able to solve this question very easily. Let's discuss this question next. What does this question say? A manufacturer produces 3 products X, Y and Z, which he sells in 2 markets. Okay, there are 2 markets, market 1 and market 2. Annual sales are indicated below. Annual sales of the products X, Y and Z are indicated below in this table. Then we have part A, which says if unit sale prices of X, Y and Z are rupees 2.5, 1.5 and 1 respectively, find the total revenue in each market. Find the total revenue in each market. There should be, and rupee 1 respectively, find the total revenue in each market. Okay, with the help of matrix algebra. How do we find that, right? So this matrix is clear. We'll get one matrix from here. Okay, what we'll get is one matrix will be obtained from here. This is 10,000. The first row will represent the first market. The second row would represent the second market. The first column would represent the first type of product. The second column will represent the second type of product. This is a matrix for sales. Okay, and when we want the revenue, we need another matrix for the price, right? Sales times price, number of items sold into the price would be actually the total revenue. So this is a matrix for sales. We can find another matrix for prices, and on the basis of, by multiplying them, we can get the total revenue, right? So this is the sales matrix, right? This is for sales. Let us call this A. Let sales be represented by A equals this, where rows represent the markets, market 1 and market 2. We could have had another market, market 3, market 4, market 5, and the columns represent the product types, X, Y, and Z, right? This is product X, product Y, product Z, right? This is a sales matrix. What about the price matrix? Let price be denoted by, be represented by matrix B. What does it say? For multiplication, right, these prices, this row will get multiplied with the column having prices, right? So what you have is prices of X, Y, and Z are 2.50, 1.50 and 1.00. This is the price matrix, and it has to be in the form of a column, right? And now we can get the revenue. Therefore, revenue can be obtained by multiplying these two matrices together. Revenue would be equal to this: 10,000, 2,000, 18,000, then you have 6,000, 20,000, 8,000. Gets multiplied with 2.5, 1.5 and 1.00. This is what I get, right? On multiplying these two, what you get is in the first row, you'll get the total revenue of first market. In the second row, you'll get the total revenue of second market, right? This is a 2 by 3 matrix. 3 by 1 matrix will give us a 2 by 1 matrix, right? So net for market 1, revenue in each market could be found with the help of matrix algebra using this approach. What you have over here is this. Let's multiply them together. This first row gets multiplied with the first column. Let me just check the numbers once a bit. 2,000, 18,000, 20,000, 8,000 and 6,000, right? So we are multiplying 10,000 with 2.5. So this is 25,000, right? 25,000 plus 2,000 times 1.5 is 3,000 plus 18,000 times 1 is 18,000 only. Then the second row will be obtained by multiplying the second row with the first column. This is 6,000 into 2.5. 6 to 12, 30, 15. This is 15,000 plus 20,000 into 1.5, which will be 30,000, plus 8,000 times 1 would be 8,000, right? This is what you get. And can you add these numbers? Yeah. What you get is a total revenue, which will be equal to 18 and 28. 46,000 is what I'm getting over here. This is 46,000. And the second row, what you get is 45 and 8 is 53,000. This is what you get, 53,000. That's the total revenue from market 1 and market 2 respectively. From market 1, we get a total revenue of 46,000. From market 2, we get a total revenue of 53,000, as you can see over here. Next, the second part of this is also there. What does the second part say? If the unit costs of the above three commodities are rupees 2, rupees 1 and 50 paisa respectively, find the gross profit. Okay. So one is the selling. This is the selling price. This is the final revenue that we get. And we also have something called cost. Okay. So same number of units, this sales matrix will be same, right? For same number of units, we have to find the cost, the total cost, the first market and second market. On the basis of that, we can find the gross profit in the two markets, right? Let's see what we have over here. We'll have to modify a few things. This final result is important, mind you. This revenue, when we talk about revenue, revenue can be represented by this matrix. This is 46,000 and 53,000. Let's keep that safe. 53,000. Yeah, let's write it over here. And now we want to talk about the cost for part B. So sales matrix would be same and the cost matrix would be different. Sales matrix would be same and let cost is represented by C equals this matrix, matrix C. which will be 2, 1 and 50 paisa. 2.00, 1.00 and 0.50. This is what you get, right? So this is the cost matrix, and once we have this, then we can find the total cost. First, let's find the total cost. Total cost would be product of this and this, matrices A and C. What do you have over here is 10,000, 2,000, 18,000. Let's write the numbers. 10,000, then we have 2,000 and 18,000. The second row has, in the second market we have 6,000, 20,000 and 8,000. The cost that is involved in preparing these products is 2, 1.00, 0.50 respectively for the three types of products X, Y and Z, right? So this product X is prepared in 2 rupees, Y is prepared as 1 rupees and Z is prepared in 50 paisa, as you can see. And the total cost can be found easily by multiplying these two matrices together. What you have is 10,000 times 2 is 20,000. 2,000 times 1 is 2,000 plus 18,000 times 0.05 is 9,000. The second row will give us the cost for the second market. What is that? 6,000 times 2 is 12,000 plus 20,000 times 1 is 20,000 plus 8,000 times 0.5 is 4,000. That's the total cost when we talk about the second market. What happens next? Next, total cost can be obtained by adding these. 31,000 is the total cost. On the first market, add 1224, what is that? 36,000 is the cost in the second market. Okay, we have revenue, we have cost, and now we can easily find the profit. Profit is simply how much do you sell for minus how much did you spend it, like how much money did you spend for preparing it. So making versus the revenue is basically the profit. This minus this will give us the profit. So let's find the profit after this. Let's get rid of this. The profit can be found over here. Profit would be actually revenue minus cost. What is that? This is 46,000, 53,000 minus what you have over is 31,000, 36,000. And the final value would be 15,000 for the first market, and what do you have get over here is 17,000. This 14 plus 3, 17,000 for the second market. This is the profit from the two markets. From the first market you get a profit of 15,000. From the second market you get a profit of 17,000. That's why final answer for this second part as well. These are parts A and B, and you can observe the practical application of matrix algebra with the help of this question, right? We could have more number of markets, we could have more number of products and the individual values of the sales. Depending upon the cost and revenue, we can find the net profits and then make decisions accordingly, right? So this is the important thing about this question. I hope you have understood the complete solution clearly, right? You can also rewind if you want and go through this question again, right? That is all for this question. Let's talk about this question. Find the matrix X so that X times 1, 2, 3, 4, 5, 6, this is a matrix again, is equal to another matrix over here, right? So X is some matrix and we are multiplying it with one matrix. Okay, we're getting another matrix. Now how do we go about solving this kind of question? Let's see. First, can you guess the order of X? So this here is a 2 by 3 matrix, this here is a 2 by 3 matrix. Now for X, if the order is P by Q, this Q and 2 should be same, that gives me Q should be equal to 2. And the final order should be P by 3, which is equal to 2 by 3. So that gives me P is equal to 2. The important thing to observe here is that X is a 2 by 2 matrix, okay? So X, let us assume X after this. Let X is 2 by 2 matrix, let us assume it is A, B, C, D, this matrix over here. Once we assume it as this, let's use this equation to find A, B, C and D. How do we find that? by multiplication, right? A, B, C, D, this matrix multiplied with this matrix 1, 2, 3, 4, 5, 6 will be equal to this matrix over here. What is that? Minus 7, minus 8, minus 9, 2, 4, 6. This is what we have, right? And let's multiply them. What you get is AB gets multiplied with 1, 4. What you get is A plus 4B. Okay. This is the first row, first column element. And this will be equal to minus 7. Okay. We can directly form equations? Yeah, we can directly form equations. The first row gets multiplied with second column, 2A plus 5B will be equal to minus 8. Okay. And 3A plus 6B will be minus 9. This is what you get. 3A plus 6B would be equal to minus 9. That's what you get over here. You actually have 3 equations. You only have 2 unknowns over here in these 3 equations. 2 more unknowns are here, C and D. We can form 3 more equations for C and D. Let's see. We only need 2 more equations, by the way. But since there are more number of equations, we'll have to check for consistency. Okay, here it will not be an issue, as you will observe, and I'll explain why. So C and D, second row, first column would give me C plus 4D. Let's see, C plus 4D, which is 2. And then you have 2C plus 5D, which is 4. And 3C plus 6D, which is 6, right? Okay. The numbers have been given in such a manner that the equations remain consistent. By the way, but in general, in such a question, the issue that generally we may face is of consistency. Okay. How do we solve for A, B, first of all? So for solving for A and B, we only need these 2 equations. This is an extra equation. We'll check this for the solutions obtained for consistency, right? What do? What we can do is simply multiply this by 2 and subtract over here, right? That's what you can do. This is equation number 1, let us say. This is 2, this is 3, this is 4, this is 5, and this is 6. The important thing for solving this these two equations is we multiply equation 1 by 2 and subtract equation 2. What you get over here is this. Please observe, this is 2A minus 2A is gone. 8B minus 5B will be 3B, which will be equal to minus 14 plus 8, which will be minus 6. This will give me B equals minus 2. Once we obtain B equals minus 2, we can solve for the value of A very easily using equation 1. Gives me A equals minus 7 minus 4B. Minus 7 minus of minus 8. What will that be? 8 minus 7, which is 1. This will give me A equals 1. We have to check equation 3. Check equation 3 for consistency, right? This is important. So what you get is 3A, which is 3. 6 times 2 is 12. 3A plus 6B is equal to 3 minus 12, which is minus 9. That is okay. This is equal to the RHS. Yes, that is okay. Therefore, the solution that we have obtained, A is equal to 1, B is equal to minus 2, is okay. That's simple now. Right. On solving 1, 2, 3, we get the values of A and B. Can we solve 4, 5, 6 to get the values of C and D correspondingly? Yes. So let's get the values of C and D now. Okay. Next part. Next, we solve for C and D. Let's use this space over here. So once again, let's multiply this by 2 and subtract over here. Equation 4 times 2 minus equation 5 will give us what? This is 2C minus 2C will go. This is 8D minus 5D would be actually equal to 3D, which is equal to 4 minus 4, which is 0. This will give me D equals 0. Is that okay? Yeah. D will be simply 0. And therefore, using equation number 4, we can get C equals what? C plus 0 equal to 2, which gives me C equal to 2. But that's not enough. We'll also have to check whether equation 6 is consistent with these values. So we'll have to check equation 6. LHS is equal to what? 3C plus 6D, which is equal to 3 times 2, 6. Is it equal to the RHS? Yes, this is equal to the RHS. This is okay. So therefore, we have obtained the values of A, B, C and D, and initially we were not asked A, B, C and D. We were asked the matrix X. The matrix X is equal to this. So therefore, what I'll write is, after this, the final answer, therefore, X is equal to A, B, C, D. That is the answer for this question over here. That's the final answer for this question over here. Is that all? Yes, that is all in this question, as you can see. Let's discuss this question over here. If A and B are square matrices of the same order such that AB is equal to BA. Okay, A and B are commutative in this case. Then prove that by induction A B power n is equal to B power n times A. Very simple. Prove that AB whole power n is equal to A power n times B power n for all n belongs to natural. Okay, let's do that. If A and B are square matrices of the same order such that AB is equal to BA. So given AB equals BA, this is given. Prove by induction. We have to prove by induction. Okay. A B power n is equal to B power n times A. Further, we have to prove something else. We'll talk about that later. But prove this. Proof by induction would imply, proof by induction would imply what? Proof by induction says that what do we have over here is A B power n plus is equal to B power n times A. So we'll have to assume a statement Pn. Let Pn is this statement. What is this? A B power n is equal to B power n times A. Let this is it. For all natural numbers n. For all natural numbers n. Now proving by principle of mathematical induction involves 3 steps. What is the first step? Well, I have to check whether P1 is true. The second step says assume Pk is true, and on the basis of that, step 3 says prove that Pk plus 1 is true. Okay, those are the steps that will follow. So step 1 says P1, check P1, P1 should be true. What do we have? A B power 1 is equal to B power 1 times A, and since this is already given, yes, this is true using this statement 1. Right? Using equation 1, this statement is true. That's not an issue, right? P1 is true. Okay. Second step, assume Pk is true. That implies that A B power k is equal to B power k times A. That's what we have, right? Third, step 3. Step 3 says prove that Pk plus 1 is true. Okay. For proving that Pk plus 1 is true, that is A B power k plus 1 is equal to B power k plus 1 times A. And for proving this, we can begin with the LHS first of all, right? We can begin with the LHS. LHS is equal to A B power k times B. Can you observe that? B power k plus 1 can be written as B power k times B. Yeah, in this manner. What else? What else? Once we have this, then this A B power k can be replaced by B power k times A with the help of that condition. Let's call this statement 2, and using 2, this can be done as B power k times A times B. This is using 2. I'll have to use 2. And one more thing that we can use over here is this AB is equal to BA. You can use 1 and we can write B power k times AB as BA. This is using what? Using statement 1. We can observe that, right? What else? This is okay. B power k times B times A, and B power k times B is B power k plus 1 times A. Now B power k plus 1 times A is what we wanted on the RHS. Hence proved Pk plus 1 is 2. Hence proved that Pk plus 1 is 2. Okay. So since step 1, 2 and 3 are done by principle of mathematical induction, we can say Pn is 2. we can say that Pn is true, and that's what we wanted to prove. Pn is true means this is true for n belongs to natural. That's what we have proved over here. Is that all? Yes, that is all. Now we have done this much. Further, prove that this equals this for all n belongs to natural. Can we go ahead and prove that as well? Yes, we can maybe prove that. Let's take a look at the second part after this. Next, what are we supposed to do in this case, right? A b power n is equal to a power n b power n. Now this can also be proved with the help of principle of mathematical induction, but in this case, we'll obviously require something which we have already proved, right? So for proving this, we'll use principle of mathematical induction, the 3 steps, but first let's write the statement Pn. Let Pn is a b whole power n is equal to a power n b power n for all n belongs to natural, right? That's what we have. Then step 1 says P1 should be true. P1 implies P1 says AB power 1 is equal to A power 1 B power 1, which is true. Right? You can observe this is AB, this is also AB. So P1 is true, yes. Principle of mathematical induction step 2 says that assume Pk is true. Assume that Pk is true. What does that mean? Pk is true implies that AB power k is equal to A power k B power k is true. This is assumed. And third, prove Pk plus 1 is true. That is AB power k plus 1 is equal to A power k plus 1 times B power k plus 1. This is important, right? AB power k plus 1 is A power k plus 1 times B power k plus 1. This is true. Let's call this statement 1. Right? And for proving this, we'll begin with LHS. LHS is AB power k times AB. This is what you have, right? AB power k plus 1 can be written as this one, right? What is AB power k equal to? As you can clearly observe, AB power k is equal to A power k, B power k. So this is A power k, B power k. This is A and B. This is the product. Right. And in case of matrix multiplication, what we can do is, since matrix multiplication is associative, we can remove this brackets and we can multiply B power k times A together. This is A power k times B power k times A times B. What is this B power k equal to? Do you remember that we have proved A B power k is equal to B power k times A. This can be done as A B power k. Right? B power k times A is equal to A times B power k times B, which is already present over here, using A B power n is equal to B power n times A, which we have already proved before this. This. What next? A power k times A becomes A power k plus 1. B power k times B becomes B power k plus 1. This is nothing but the RHS of this, right? And this is equal to, since this is equal to RHS, which implies Pk plus 1 is true. By principle of mathematical induction, we can say P1 is true, Pk is true, and whenever Pk is true, Pk plus 1 is true. Therefore, by principle of mathematical induction, we can say by PMI, we can say that Pn is true. What is Pn? Pn is this statement. For n belongs to natural. This is true. Right? That's what you can observe over here. And by principle of mathematical induction, this is true. And therefore, that's the complete proof for this question over here. That's the second part. Further prove that this equals to this. This part we have already solved, and this is the second part of this same question. That is all for this question over here. Right? Let's discuss this question. What do we have? We have to choose the correct answer in the following questions, and we have 4 options based on this question. If A is some matrix alpha, beta, gamma minus alpha, and A square is equal to the identity matrix, then which of these is correct, right? Let's solve. So A square is equal to I is given, which implies A times A will be equal to the identity matrix. Now what is matrix A? We are using this equation, right? Matrix A is alpha, beta, gamma minus alpha. This is alpha, beta, gamma minus alpha, which is equal to the identity matrix 1, 0, 0, 1 over here, which is equal to the identity matrix 1, 0, 0, 1 over here. And once we know this, what next? We can multiply the LHS. What you get is alpha times alpha is alpha square, beta times gamma is beta gamma. This is the first term. What next? We have alpha beta minus alpha beta, which is gone, gamma alpha minus alpha gamma, which is gone, 0. Then you have beta gamma and plus alpha square. Okay, beta gamma plus alpha square, which is equal to this 1, 0, 0, 1. Since this is equal to this, we can directly compare after this, and therefore alpha square plus beta gamma will be equal to 1. 0 and 0 are equal, and beta gamma plus alpha square equal to 1 is the one and the same thing. So this is what I am getting. Now check which of these options is correct. Alpha square plus beta gamma is equal to 1. So 1 minus alpha square minus beta gamma will be equal to 1. This is option C, that is equal to 0, right? 1 minus alpha square minus beta gamma will be equal to 0. This implies 1 minus alpha square minus beta gamma is equal to 0, which implies C option is correct. That's the answer for us, right? Is that all? Yes, that's all. Let's see this question. We have to choose the correct answer in the following. If the matrix A is both symmetric and skew symmetric, then if the matrix is both symmetric and skew symmetric, in that case, what kind of a matrix will it be? Will it be a diagonal matrix, a zero matrix, a square matrix? Now, what does a diagonal matrix look like? Diagonal matrix would have diagonal elements and non-diagonal elements would be 0. Okay. What else? Zero matrix will have all elements 0. And A is a square matrix. Okay, both symmetric and skew symmetric. Square matrix, yes. A will be a square matrix. For symmetric and skew symmetric, A is supposed to be a square matrix. Okay. So, just for this is correct. But what about symmetric and skew symmetric? Conditions of symmetric and skew symmetric. Do we have anything special in that? Yes. Let's see. If A is both symmetric and skew symmetric, then what kind of matrix will A be, right? So A transpose is equal to A as per symmetric, right? A transpose is equal to minus A as per skew symmetric. And since this is true, therefore A is equal to minus A, which implies 2A equals 0, or that further tells me that A is equal to 0. Basically, A is a 0 matrix. That's what we observe. A matrix which is both symmetric and skew symmetric will be a 0 matrix. So the correct options that you will have over here is skew 0 matrix is also okay. In case of diagonal matrix also, what happens is the non-diagonal elements are 0. What happens to the diagonal elements? Can the diagonal elements be 0? They may or may not be 0. Right. So a matrix which looks like A, B, C, 0, 0, 0, 0, 0, 0. This is a diagonal matrix. The elements A, B and C can also be 0. So a 0 matrix can also be a diagonal matrix, can also be said to be a diagonal matrix. But then, if all of these options are correct, is this a one or more than one K type question? No. You have to choose the best possible answer. Choose the best possible answer. Although in this case, diagonal matrix, I'll avoid saying this is a diagonal matrix, but A is a 0 matrix. Yeah, this is one of the answers that should be there. And for symmetric and skew symmetric, the answer C should also be marked, right? But then, since only one is given correct, I'm marking B. But then I've also explained that A, B, A and C did nothing wrong by coming over there. And yes, they could also have been answers. Right. A is a 0 matrix. This is what the NCERT wants you to mark. But then A and C, there's nothing wrong in that as well. Right? As per definition, right? A is a square matrix and this. Then this, right? And what else? Is there anything special in this other than that, right? There's one more thing that is supposed to be taken care of is you should understand this question from another perspective, yes. And why they have skipped A and C, the one reason that may be true for skipping A and C is that all diagonal matrix do not satisfy this. All square matrix do not satisfy this, but all 0 matrix would satisfy this. All 0 square matrices would satisfy this, mind you. all 0 square matrices will satisfy this. So there also there lies a catch. If that is the logic which they have applied, then they should have mentioned that A is a 0 square matrix, right? In that case. But this statement is if then statement, and as per concepts of mathematical logic, mathematical reasoning, A and C could also have been correct, right? So is that all? Yes, that is all in this question over. Let's discuss this question. If A is a square matrix such that A square is equal to A, then I plus A whole power 3 minus 7A is equal to what? Okay. A is a square matrix such that A square is equal to A. So how do we approach this? I plus A whole power 3 minus 7A will be equal to what? I plus A whole power 3 can be expanded. Since I and A are commutative with each other, A is equal to AI. This can be done as I cube plus 3I square A plus 3I A square plus A power 3 minus 7A. Okay. It is given that A square is equal to A, which gives me A power 3, which will be equal to A square, which will further imply A power 3 equals A. This is something which will imply. Right. So this is I plus 3 times A plus 3 times A square, which is A, plus A cube, which is A, minus 7 times A. Okay. This is 7A minus 7A. That will get cancelled, and this will be equal to I only, and this is my correct answer for this question. That's all? Yes, that is all in this question. And with this, we come to the conclusion of this exercise, the miscellaneous exercise based on matrices chapter, right? We have a live session upcoming in some time, and based on the chapter matrices, please attend that live session as well. If you haven't liked and shared this video, please like this video, share this video with your friends, and also subscribe to the channel of Vyas Edification for further latest updates related to all activities of JEE, NEET and board examinations, right? Till then, all the best.